Virtualization is one of the most important concepts which everybody must be aware of in this world of AI. Especially if you want to become an AI engineer, then understanding the fundamentals of virtualization is the key. But as always, we get overwhelmed with a lot of terms like Dockers, virtual machines, hypervisors, Kubernetes, and stuffs like that. So if you watch this video until the end without skipping any section, I'll promise you'll get a clear understanding of all the core concepts of virtualization. So virtualization is a technology that creates virtual simulated version of computing resources like servers, storage, networks, and operating systems from a single physical machine. That is the key. From a single physical machine using a software as a layer to abstract them from the hardware, right? So that's what virtual machine is all about. It's all about creating a virtual simulated computing resources on a single physical machine using software as an abstraction layer. But what benefits we get when we do this virtualization, right? So when we do this virtualization, automatically we get improved security. The most important thing is isolation. We isolate things using a container or a virtual machine or something like that, totally isolated resources. And then it's a lot of cost saving. If you have one physical server, you can build multiple isolated virtual environments. It could potentially save a lot of cost. Okay. And easier for disaster recovery, flexibility. We have a lot of flexibility to play with and efficient resource utilization of that single server. And then the server consolidation. We can consolidate all that into a single server, right? So these are all some of the key benefits of virtualization as such. So now let's look into different virtualization technologies. So to start with, the first thing is the virtual machine, and the second thing is the Docker. So these are all the two main things which we are going to look into it today. And it all starts with a hardware layer. So bottommost layer is the hardware layer. So we'll see all the layers on top of it, but on what is the difference between the virtual machine and the Docker layers, right? So on top of the hardware layer, the important software abstraction layer which comes into play, which is called hypervisor. So this hypervisors create a virtual machine as much as we want, as many as we want, right? So it uses the hardware, create a virtual partition of all the hardware resources like CPU, storage, memory, everything, and then create a virtual machine which is dedicated with that amount of resources. And then on top of that virtual machine, we install the operating system, which could be like a Windows or Linux or anything. So these are all the layers of a virtual machine, right? So similar way, if we look at the Docker, it starts with the hardware, but it has a different layer in between, right? So it has a kernel which acts as a bridge between the operating system and the hardware. So there is a operating system on top of it, and on top of it there comes the virtualization abstraction software, right, which is called in this case a Docker engine or a Docker. So in this case it is not a virtual machine, it is called container, Docker container, and you can create as many as containers you want. But inside that container, what we have is the application we wanted to virtualize and the library, dependent libraries, which are needed for that application to run inside that container in a virtualized manner, right? So like that, we can keep creating different containers within the same operating system. What this allows is a process level isolation rather than a machine level, physical machine level isolation. So that's the key difference between these two levels of Docker. So the one important thing which we need to note is the Docker and the hypervisors are called the abstraction softwares, which we saw as part of the definition, right? So then the another important thing is when a hypervisor sits on top of the hardware directly, that is called type 1 hypervisor, right? So there is another type of hypervisor where hardware is the starting point, but we don't install hypervisors on top of it. We install the operating system, and this operating system is called the host operating system. And on top of the operating system, we install hypervisors. So for example, some of the hypervisor softwares are VirtualBox, VMware Fusion. All these are some of the hypervisors which got installed on top of the operating system. So that means we have already an operating system which is called host operating system. On top of it, we install a hypervisor, and then on top of it, we create some virtual images, and which provides like different operating system within that specific hypervisor. So in this case, the operating system within the virtual machine is called the guest operating system. There are two operating systems. One is the host operating system, which sits on top of the hardware, and there is a virtual machine's operating system, which sits on top of the hypervisor, right? So the hypervisor enables that. So this is called type 2 hypervisor. Now let's look at the differences between this virtual machine and the Dockers, right? So the virtual machine, as we keep seeing at a high level, it's a strong machine level isolation, can run Windows VM on a Linux VM. That's very important. So in this case, it is this operating system could be a Windows, and we can run a Linux VM on top of the Windows. Absolutely, it would run. That is what that machine level isolation means. But this provides, as we keep talking about, the application or the process level isolation, and that is what it does. We cannot run a different operating system within a container. Okay, so that's something we need to be aware of. Okay, so in this case of virtual machine, it boots as a full operating system on the hardware. It is pretty much like booting a server on its own. So in that case, it is very slow. But on the other side, if you think about containers, it is very pretty lightweight because it's not starting up the server from the go. So it is just starting the processes needed to run the application. So it's kind of a small isolation, sits on top of the same operating system and kernel. And then think of it like virtual machines are a hardware level virtualization, and the Dockers are like virtualizing the operating system to share the same kernel but run different applications inside that. So it is a operating system level virtualization. So it sits on top of the operating system. It is a hardware level virtualization, virtual machines. It sits on top of the hardware. That is what we saw here. It sits on top of the hardware. That's why it's a hardware level isolation. This Docker sits on top of the operating system. So it's a OS level virtualization with sharing the same kernel of the OS. The next important thing is when we would use virtual machine versus a Docker. So we use virtual machines when there is a OS level isolation needed to testing, right? Legacy apps and strictly security. We want to set up a strict security policy and test our applications. In that case, we would prefer a virtual machine. On the other side, if you need an application level isolation with a consistent environment across different environment, in that case, it is pretty much easy to go with a Docker kind of a setup. So to summarize, so we saw what is a virtual machine and what is a Docker and the different layers of it. So in case of virtual machines, there are two types of hypervisor, hypervisor type 1 and type 2. Type 1 sits directly on the hardware. Type 2 sits on top of the operating system. And then in case of Docker, the Docker engine sits on the operating system as always, but it only creates the small container, which contains only the application and the libraries, not the complete different OS. So that's what it does. So the OS and the kernel are shared by the Docker engine. In the case of hypervisor, it creates a separate operating system on its own to run in a more isolated environment. In case of type 2, it runs two different operating systems distinct from each other. One is the host, where it hosts the hypervisor, and then the other one is the guest operating system. So at a high level, virtual machines are for more OS level isolation needs, and application level isolation needs, we use Docker. So now that we know the Docker, so now let's see why there is a need for Kubernetes. So a lot of talk about Kubernetes and is it a replacement for Docker or how it works. Let's look at a simple example and see how that Kubernetes come into play. So let's take a small example of a container. Okay, so think of this container runs an application. Okay, simple application like our web application, which is our personal homepage or something like that. So this application is deployed inside a container and exposed as a website. So people are using it. Suddenly, our user base is increasing and a lot of people are coming in. So what we need to do, this application is not able to scale on its own. So what we could do potentially, we can create another set of same stack and deploy another container on a different hardware. This way we can establish it, but the users don't know there are two servers. Then now we need to introduce a layer called load balancer, which enables the user to distribute the load between the two containers. Now it's all working perfectly all right. All the users are able to access both the containers. The load balancer is taking care of splitting the load and spreading across two containers. Everything looks good. So, but what will happen if there's a huge set of another users coming into play? Then probably one answer is, yeah, we could create one more similar set of infrastructures and load balancers and keep adding resources one by one. It looks good from an adding perspective, but think about now there is a change to an application. If you want to deploy a change to an application, how complicated this environment or setup is going to look like. You need to update all the containers, change all the applications, small change, big change, whatever it has to get deployed, all the applications, load balancers have to be maintained, all these things has to be manually maintained. Okay, that becomes a big problem in terms of orchestrating all these workloads in a huge application server setup, which has like thousands of containers running. And that's exactly what the Kubernetes are going to solve for. It is an orchestrator for managing Docker containers. So that is where the Kubernetes come into play. The power of Kubernetes is it exactly does the orchestration in a massive scale using an easy process. All we need to do is just configure the key parameters of the application size, how it needs to scale, what are the minimum instances it needs to run always, how the traffic is being distributed, all that stuff we need to configure. So how do we do that? So that is where the master node comes into play. So the master node is kind of the key node. I'm going to explain Kubernetes at a very, very high level, but there is a separate video I'll make with a more detailed version of a Kubernetes alone with a simple example of how this things is going to work and with a full-fledged demo. So for now, at a high level, all we need to understand is Kubernetes is a simple Docker orchestration layer, right? So it orchestrates all the deployment, updates, and load balancing, all that stuff, right? So that is what it does. And who does it? The master node. The master node knows it has a lot of different components like schedulers and control plane and stuff like that, which is what is kind of used to manage the containers underneath that. So now we have these containers as same containers, the stack as we saw here. But how does the master node knows this is a container which is running there? I need to control this and all. That's where that Kubelets and Proxy is another small piece of software which we run on top of this server. That is what tells the master that, oh, I know there is a container running on the server which I can manage, right? The kubelet and kubeproxies are small pieces of software which runs on every node which has our containers in it, right? And these nodes are called the worker nodes. The nodes on which we run our containers are called the worker nodes, right? So that is where we deploy the kubelets and kubeproxy. So now that we know there is a master node and a worker node, all we need to do to make that node as a worker node is to just install that kubelet and kubeproxy on those servers. And that's what we need to do. So now the important thing is the master can interact with this kubelet and kubeproxy to manage the containers running on that, how many containers we need to run. If the containers goes down, it needs to bring a new instance of the container. All that are managed by the master as per the instruction set up in the master. So one more thing important we need to know about is when we make a normal container into a Kubernetes worker node, the containers where it sits, that's called a pod, right? So in technically, this is kind of a logical space where the containers run, okay? So inside a pod, we can run more than one containers, okay? That's all managed by the master node to see how much resources are available and can it take more container and stuff like that. All that things are managed by the master node, right? Technically, so that pod is the term we need to understand. So whenever we say there is a worker node, there is a pod, and inside that pod, we could potentially run one container or as many as containers based on the hardware availability. The master will decide to run as many as needed, right? So one more important quickly I wanted to highlight here, Kubernetes is a flexible container orchestration platform that supports multiple container runtimes, not just the Docker. So Docker is an example I used in this video, but it supports any container runtimes which follows a standard interface called Container Runtime Interface CRI. So these are all two examples of other containers generally used in standard cloud providers, that is like GKE and EKS, which is Amazon and Google's Kubernetes engine. So they use container D as a runtime by default in current versions. And CRIO, this runtime is specifically an optimized runtime for Kubernetes to kind of use a lightweight alternative for Dockers, right? So I just want to highlight. So Kubernetes is a generic container orchestration service, not just a Docker orchestration service. It can orchestrate any containers using different runtimes. So that's all pretty much about Kubernetes. So Kubernetes at a high level is an orchestration layer for deploying, managing, maintaining, running containers in a huge server setup. Okay. So with that said, we have come to a conclusion of the virtualization video. Please subscribe to get more notifications on videos like becoming an AI engineer and more hands-on AI videos and stuff like that. Until then, see you. Bye.